Hey everyone, welcome back to the channel. Today, we're diving into Agentic RAG, Retrieval Augmented Generation, and comparing single-agent and multi-agent approaches to help you understand their architectures and applications. I'll be using precise, domain-specific terminology to break this down, so you can apply these concepts to your own AI projects. Let's get started. First, let's look at the single-agent Agentic RAG workflow. The process begins with an input query from the user, which is passed to a retrieval agent. This agent is responsible for fetching relevant information to augment the language model's response. The retrieval agent interfaces with various tools and data sources, such as web search for real-time information, vector search X and vector search Y for embeddings-based retrieval from index datasets, and raw data sources for unstructured information. The agent constructs a prompt by combining the query with the retrieved data, ensuring the context is relevant and concise. This enriched prompt is then sent to the large language model, LLM, which generates a response by leveraging both its pre-trained knowledge and the retrieved information. The response is returned to the user, completing the cycle. This single-agent setup is straightforward and effective for simpler tasks where one agent can handle both retrieval and generation. Now, let's explore the multi-agent Agentic RAG framework, which introduces a more sophisticated, distributed approach. The process also starts with an input query, but instead of a single agent, the query is first processed by a retrieval router agent. This router acts as a coordinator, analyzing the query to determine which specialized retrieval agents are best suited for the task. For example, retrieval agent X might focus on vector search X to fetch embeddings from a specific dataset, while retrieval agent Y handles vector search Y for a different data domain. Retrieval agent Z could specialize in web search, email retrieval, or chat history, depending on the query's requirements. Each agent retrieves data from its designated sources, vector search X, vector search Y, web search, mail, or chat, and passes the information back to the retrieval router agent. The retrieval router agent then aggregates and refines the retrieved data, constructing an optimized prompt that combines the query with the most relevant information from all sources. This prompt is sent to the LLM, which generates a response by synthesizing its internal knowledge with the augmented context. The response is then delivered back to the user. The multi-agent setup excels in complex scenarios where diverse data sources and specialized retrieval strategies are needed, enabling scalability and modularity through agent coordination. See you in the next one.